All right, let's talk about wind power. To power our future, we're building turbines that are just massive. But with that incredible size comes this equally huge engineering problem, one that's totally hidden from view. So let's get into it. And I mean, we are talking about absolute giants here. These things make the turbines from just 10 years ago look like toys. You've got onshore rotors spanning 174 meters, and offshore? Well, they're looking at a staggering 250 meters. It's just incredible. They're getting taller, way more powerful, and we're pushing them further and further out to sea to chase those really strong, steady winds. But you know, what's really fascinating about all this isn't just the giant spinning blades. Nope. It's the part you can't see, the invisible challenge that's buried deep underground, or even under the ocean. I mean, just think about it for a second. You have this towering structure, right, with these huge blades catching hurricane-force winds. And if it's offshore, it's also getting pounded by waves day in and day out. The stress on these things is just immense. So the big question is, how on earth do you keep them standing? How do you anchor these titans, especially on something as shifty as the seabed? Well, the answer is the foundation. It's truly the unsung hero of wind power. But here's the catch. These heroes are expensive, like really expensive. Building a foundation that's strong enough can eat up almost a third, up to 30%, of the entire project's cost. That's a huge chunk of cash. Okay, so here's the logic, right? If you can figure out a way to build a smarter, cheaper, more efficient foundation, boom, you make wind power way more affordable and accessible for everyone. And that is exactly what this incredible research we're looking at today is all about. So this entire explainer is based on a master's thesis that looks at this really clever idea called a skirted foundation. Now, don't think of a flat concrete slab. Instead, I want you to picture a massive, hollow steel cylinder, kind of like a giant bucket with no bottom, that gets pushed right into the seabed. And how they install it is it's genius. So they lower the cylinder to the seafloor, then they start pumping water out of the top, which creates this massive suction force that literally pulls the foundation deep into the soil. It's just like when you're at the beach and you push an upside-down bucket into the wet sand. The sand trapped inside creates this solid plug, making it super, super hard to pull out. That's your anchor. Okay, it's a fantastic idea in theory, right? But how do you prove it's going to work? I mean, how do you know it can handle decades of getting hammered by the elements without, spending millions of dollars to build a real one? Well, the answer is you build a virtual one. And that's exactly what researchers at Bu Ali Sina University in Iran did. They built this incredibly detailed 3D digital model of the foundation, the soil, the whole shebang. They used some seriously powerful software called Plaxis 3D to create essentially a virtual laboratory. And in this lab, they could just unleash hell on their design. We're talking gale force winds, massive waves, the constant shaking from the turbine blades. They simulated everything. So the big question, how did this new design actually perform when it got pushed to the absolute limit in this virtual world? Well, the results were pretty incredible. What they did was compare a standard, regular foundation against one with their new skirted design, and the difference, well, it wasn't just a little bit better, it was a massive leap. Okay, so get this. The research found that just by adding that skirt, the foundation's bearing capacity, which is basically its strength, its ability to take a punch without failing, went up by, wait for it, 268%. Just wow. And this chart really puts it into perspective. Look at that jump. This isn't some tiny incremental improvement. This is a complete game changer. We're talking about making the foundation almost 4 times stronger. That's huge. And it wasn't just about raw strength either. The skirted design also made the whole thing way more stable. It reduced how much the foundation settles or tilts over the years, which you can imagine is a major worry for these incredibly tall, top-heavy structures. And, maybe most importantly, it worked incredibly well in loose, sandy soil, the exact kind of environment where normal foundations really struggle. So, okay, this is all fantastic engineering, but what does it all mean? What does a stronger, more stable foundation actually do for the future of green energy? Well, for starters, it means we can build stronger wind farms for less money. A more efficient design means you need less material. We're talking less steel, which cuts down costs. Plus, that suction installation method, it can be way faster than the old way of hammering giant poles into the seabed, so it saves time and money. And remember, this isn't just some fantasy computer model. To make sure their simulations were spot on, the researchers checked their work against real-world data from an actual test site in Frederikshavn, Denmark, so this digital breakthrough is firmly grounded in reality. Really, the main takeaway is simple. This design just works better. Period. And technology like this could be the key to unlocking offshore wind in places we could never build before. It could open up huge new areas of the ocean for generating clean, renewable energy. So as we keep building these turbines bigger and reaching higher into the sky, it's pretty amazing to think, right? The key to unlocking a renewable future might not be up in the wind, but in the brilliant engineering hidden deep, deep beneath the waves.